everyone, welcome back to the Internet Report, where we uncover what's working and what's breaking on the internet, and why. This week, we're talking proactive optimization and also discussing disruptions at ChatGPT and Grammarly, as well as insights from other recent incidents. I'm Barry Collins, and I'll be hosting today with the amazing Mike Hicks, Principal Solutions Analyst at Cisco Thousand Eyes. As always, we've included chapters in the episode description below, so you can skip ahead to the sections that are most interesting to you. And if you haven't already, we'd love you to take a moment to give us a follow over at Spotify, Apple Podcasts, or wherever you like to listen. Let's start with that incident at ChatGPT. I asked Mike what he saw there.
So ChatGPT was impacted by, it was actually a degradation, and it was sort of followed by disruptions on consecutive days. So early in November, on November the 7th and 8th, these were actually confirmed by OpenAI on their status page.
Mike said that it appears that November the 7th issues might be connected to an early disruption observed on November the 4th.
The root of these incidents may have actually been corresponding to some work that started earlier. And it looks like what they were doing was sort of some of this reconfiguration to sort of improve performance. Now, I say that because what we actually saw was improvement in terms of what the page load coming down. But what actually happened then, so the first sort of problem that occurred like on November the 4th, 3 days before they actually acknowledged the outage there, was that users reporting that there was some unreliable services and sort of users seeing sort of 404, so unavailable type of errors coming up. So these problems weren't officially acknowledged, but the issue did actually return sort of these days later when the formal statement about the disruption was put out there.
This disruption, as you say, appears to have been caused by OpenAI implementing changes designed to optimize ChatGPT's performance. Tell us why it's important to have full visibility of your service delivery chain during the optimization process.
So let me just say, we actually make an assumption that's what they were doing. And the reason we're saying that is because what we saw was obviously these disruptions, and these were functional disruptions. So this tells us a couple of things. So first of all, we're actually making changes potentially into the back end. So we're not having these network outages. We can actually reach services, but there's some functions we can't actually get to. Then if you actually look at how sort of things are constructed, and what we're talking about there is the components that make up that service delivery chain. So these are all the dependencies in terms of reaching this service itself. So it could be resolving the name. It's actually then how stuff is directed in the back end. So when you make a query to try and understand what's going on, we're making that connections in the back end there. What then happens is sort of we're now made up of maybe thousands, maybe millions of disparate components that sort of make up this together. They all have to work together seamlessly. So you've seen these pictures of all the cogs and wheels, and every part is important. And this is critically true in this overall service. It only takes one of these to sort of break, to have this service unreliable. And it only takes one function to fail. It's great that you can get to ChatGPT. And in this case, there was sort of these 404s and this unresponsive stuff. But if I actually can't use it, or I can't actually, any application, I can't use a function, I can't search on a database, then it actually becomes sort of useless. So although I'm actually making these service level agreements because I'm actually reachable, it's available, I can't actually see what's going on in the back end there. So when we look at this, and when we consider this service delivery chain, there are things that we need to sort of take in consideration. What are those components that make everything together? And we actually effectively have this capability to optimize each one of those. But it's also in this issue when there's some sort of disruption, as it was in this case, trying to understand particularly which component it is. Because that then comes down to attribution. Whose responsibility it is to resolve that problem so we can make the process go faster, or we can actually continue to work and get around there. And as we mentioned in some previous blogs, this concept of it may well be that you can't do anything. So you just have to sit and wait. I can't actually sort of run that particular application that particular day.
Any change you make to a service can have unintended consequences, as we perhaps witnessed here. How do you best guard against that?
Again, it's really having this visibility across the complete service delivery chain, understanding what components are in there, and knowing what the right hand's doing type of thing. So you might not have specific control over every component within that service delivery chain. Some of it are way outside. You're using third-party dependencies. It might be an API gateway, it might be something that you don't have any control over. But if you actually know what it is and what's going on there, and the reason I say you don't have any control over it, you don't necessarily know what changes are being made. They might be updating it with a software patch, might be doing something from there. But if I know that component within my service delivery chain, I can understand where there's degradation. And we've seen this quite a lot when there's been a change. And if you think about how a lot of software is developed, consider some of your browsers. We're getting quite a few pushes a day when there's updates occurring. That isn't necessarily changing the entire code base. What it's doing is it's changing a module of it. Now, if that particular module then might have follow-on consequences. Now, that person, that when they're doing their functional testing of that, said, yep, it works, everything working on that one there. But without visibility, or at least context across that entire service delivery chain, I don't know what is impacting here. So I'm not necessarily always going to be aware of what changes are being made on each component, or how often a service patch or whatever is being pushed to it, or optimization process is being done. But if I actually have the ability to sort of see right across, holistically across that service delivery chain, then I'm in the best position to sort of guard against those. And even just a question of notifying very quickly, or phoning up, have you made a change, or sending requests there, have you done something to it? Because there might be an instance where you can just roll it back, or at least you're aware that it's that component that's actually causing us to sort of degrade, and therefore we can actually take steps to mitigate it or remediate it.
Talk a bit more about how ops teams can help businesses move from a break-fix model to this type of proactive optimization that it seems OpenAI may have been doing.
What happens in a break-fix scenario is you're alerted to there's a particular signal, goes out, we can see there's a problem, users are screaming, all this type of stuff's happening. So therefore, we can actually go in and we make the change. And great, having that visibility, that service delivery chain allows me to reduce that time it takes to get it. But I've had an event that has been user impacting. Now, if I get to this state where I'm actually starting to take those components and I'm understanding that there's this warning sign that the signals that we're starting to see are creeping up. So think of it like sort of seismic rumbles in the ground. We're starting to see some sort of evidence of something that potentially, when we see this pattern, it doesn't end well. So you can actually use those as sort of triggering events. But more importantly, I can actually start to combine those sort of signals together and understand, all right, when I start to see a increase in performance at component A, at a load balancer, for example, or the time it takes me to resolve a name, I can actually say, if that goes any greater than that, then I'm actually going to start to actually degrade the service completely. It's going to go out and we're going to have a failure. Or if it's a single point of failure, I'm going to have a performance degradation. So prevention is better than cure. If I can get to this state where I'm actually understanding the signals, the warning signs that mean there's going to be some outage, identifying where these potential bottlenecks are within my service delivery chain from all my mesh of my components put together there, then I can actually start to improve the performance of those. I can optimize our components. So there's a twofold effect. One, it allows me to avoid the impact to my end users, but also more importantly, it allows me to go into continuous improvement model. So whereas I'm actually just sitting at this base level and, we talked about the ChatGPT page was, let's say, sitting at X number of seconds and we've halved that down from there. If I actually don't ever make any change to that, I'm always going to be sitting at that. And how many different transactions can I actually compute there? Well, think of it in the term of a bank. If I'm transacting on an e-commerce site, if I transact every 4 seconds and that's as fast as I can go, that's my normal. If I can understand there's ways to improve that and I can drop it to 2 seconds, in theory, what I've done is I've actually doubled the amount of transactions I can complete. So by actually improving the optimization, I stop this situation where I'm impacting my users, but I'm also continuing to improve the service and therefore affect the productivity and the bottom line.
Grammarly experienced an issue on November the 8th. Here's Mike to explain what happened with this incident.
A proportion of the users were unable to log in. And when I mean log in, they could actually get to the server, but they couldn't edit the documents. They couldn't access their account settings to switch on the functions themselves. And then some of these users also then couldn't actually see the suggestions or the corrections from Grammarly. So again, we're talking about functional components within the system. The fact we could actually get to the server suggested that essentially we're looking at a network problem itself. So we're looking at stuff that was on the application side as opposed to the network. If I'm then looking at the basic Grammarly functions, what we observed was the ability for a proportion of users to actually connect to an associated service. So we're sort of confirming that there were no significant network issues associated with disruption. So we're looking again very much on the application side and not looking specifically at the network components, which gives us where we're going to look. The other thing that kind of told us what was going on here is that the issue appeared to be intermittent. So when we're looking at the patterns of this, we saw connectivity, then we saw it drop when you're making the calls to these back-end systems. And again, it was impacting users in different parts of the globe. So we didn't have a sort of global outage. So we're looking at some sort of, depending on where we're connecting to a particular server, where that information or that load balancing system is actually forwarding that request to. So there's real intermittent stuff in the back end there.
Explain how your analysis of the page load revealed the problems here and why it was only affecting a portion of Grammarly's users.
When we're actually looking at this, we're looking at effectively how that page is built, so how the components are going or what services they're calling themselves. So depending if they were calling a particular function that was in the back end, would potentially sort of see how they were impacted themselves there. But also then it was how they actually went to it, i.e. the workflow, the sequence they went. So if you think about how we go to that page, we're not following a set workflow. I might actually go and get it to suggest to me to do rewrite, improve this section, write it as a TLDR, all those things that are in Grammarly there. But that's not a set use flow across everybody. And then so what happens is we actually have this page loaded, and then we actually make specific calls going into these back ends. So depending on how those sort of sequences came about was then how you'd actually see that. So this is not necessarily why it's impacting others. So it may have been some functions that weren't actually used ever. So we're never actually going to do that. So users wouldn't have actually impacted. Might not have gone to the settings, might not have actually wanted to do an improved passage or whatever they were choosing in there. So the different sequences themselves in terms of the workflow would have potentially dictated who was impacted and who wasn't impacted.
Now we move on to our outage roundup. In brief summaries of incidents that Mike has observed recently. Netflix hosted the most streamed global sporting event ever on November 15th with the Jake Paul versus Mike Tyson match. But it didn't go entirely smoothly for some viewers.
There's reports of buffering and freezing when people were trying to sort of watch it. So it was actually sort of froze for an amount of time and the screens, some of the images coming down were pixelated. There were sort of various reports coming around from around the globe. A couple of key things here. One, we're thinking about Netflix's architecture typically and how they sort of utilize CDNs to deliver this stuff. They're normally a streaming service where they deliver this stuff. So not everybody's looking at the same content typically all the time. You know, you're putting down your sort of local content there. So we're coming from a single source at this point to sort of stream that out across the network. This actually wasn't their first attempt to actually do this. I think this was something like their ninth attempt to do a live broadcast of a system there. So they actually understood essentially what the architecture was. So there's various theories about potentially what could have actually caused this. As I said, they're effectively using a single CDN to deliver this service. But really it sort of comes down, I think, to load the requirements to actually deliver this across to all these subscribers at that moment in time. Everybody wanted watching at the same time, as well then as the way the CDN infrastructure is sort of architected to deliver that system.
Bluesky has seen a recent surge in users, but the social media platform experienced a pair of issues in mid-November. What did you see here, Mike?
So there was a couple of issues here. The first actually manifests itself as slow loading feeds and notifications. The second was actually attributed to third-party networking services, which appeared to coincide with Bluesky's highest traffic ever day. So as people started to migrate to the system. On the application side, so the first issue, we sort of saw messages like invalid handling, which suggests an ability to connect to the back-end services themselves. Users report experiencing issues like links are not working and various random errors, blank screens, basically unable to sort of get the feed down. So this suggests that we get to the system itself, it was actually the content, the request in the back end that was not being actually retrieved there. Now, the root cause of network issues is still a bit more uncertain. One carrier did actually report issues around the same time, but it's unclear if it's had a flow-on effect and whether it's network-related problems were located elsewhere in the end-to-end service delivery chain. The existence of multiple signals indicating potential points of failure sort of point to something on this network stuff in terms of how we actually got the path out there. It could have been attributed to load coming through a particular area, but I say there isn't any sort of definitive evidence to say that, besides to say there was some sort of network issue impacting connectivity to the system itself.
Salesforce was affected by a global outage on November the 15th that affected 5 of its data centers. What triggered this issue?
Now, what we saw was a series of server-side errors, and these included multiple things like page and resource not found and various timeouts. Timeouts we actually saw appeared to be connections reset by peer. So it wasn't just simply timing out. It was actually sort of sitting there, and then you get this error came back, which was reset by peer. Now, there's various reasons why this can happen, but what typically it refers to is when the actual peer crashes. As it's trying to forward it, it sort of closes the connection itself, and it comes back and says we can't get there. This inconsistency we actually saw when you see these timeouts sort of suggests some sort of a domino effect that caused greater load coming up and ultimately led to this system crash. And as we started these services restored, what we observed through our tests at Thousand Eyes, we saw these 500 internal server type response codes, which again are server-side errors, which say the service is unavailable or we can't reach it. The key to this is that this issue followed a scheduled change to environment. Now, Salesforce reported that they believe this was contributing factors, not the root cause itself. But it wasn't then possible to simply roll back the change because they said this wouldn't actually resolve the issue. It appears that the change actually triggered sort of high levels of network traffic, which then led to this domino effect that we saw, which subsequently impacted the database stability and then caused the crashes and the ability to actually reach the services in the back end.
Verizon customers experienced internet issues on November the 12th. Your analysis suggested it was a software issue rather than damage to physical infrastructure. Explain why that's your working theory.
When we actually saw the issue, it was restricted to sort of a local area. So there's various areas on the East Coast of America who actually had this service. Now, to classify that was depending on sort of where that service is available. But if we're actually looking at physical cable, so a backhoe goes through a cable or something breaks a particular fiber, it could have manifested itself in the same way in terms of you actually have this breakage in the local connection, people can't actually get onto theirs. But if there's a break in the cable itself, what that involves is a truck roll, i.e. someone's got to go out and fix this problem. Whereas if it's some sort of software configuration, then the restoration time, once it's identified, is far quicker. Now, specifically when we're talking about a software issue, we're talking not in the application terms, we're talking in some way in terms of the network configuration itself. So this was restricted to the Verizon Fios environment itself, and it was these local areas there. So it could have been something within that system, that local system there. But I said the time it actually took to resolve it and the disruption that then in terms of the users who are impacted by that in location sort of leads itself to the fact then we weren't looking at some sort of catastrophic physical failure, but rather something within the software system itself at that configuration plane.
Thanks for the deep dive into those outages, Mike. And now let's turn to the overall outage trends and what we've seen over the past few weeks.
Across the week of November the 4th to the 10th, the global outage actually decreased by 5%. This went from 187 to 178. Now, the next week, we saw a sharp rise in outages, rising to 250, which is a 40% increase. The US outages rose by 30% in that first week, and it was followed by a subsequent rise again by 44% in that following week, with numbers going from 112 to 161. Now, from November the 4th to November the 17th, there was 64% of all outages occurred in the US. Now, this is the highest US outage level this year.
As you said, that 64% figure is much higher than normal. What do you attribute that to?
Well, as you look at this rise in the percentage of US-centric outages, it means that the majority of those outages are occurring on US-centric interfaces, infrastructure itself. Now, if we actually look at the type of outages we have, we're actually sort of seeing where they're occurring and the time of day they're occurring. Now, if we actually also look at the time of year we're running into a holiday period in the US. So what we actually started to see is effectively not a rush as such, but an increase in the activity of maintenance or scheduled maintenance work that's occurring within that US infrastructure itself. This is fairly significant, this 64%. It differs from what we've seen in previous years. We've sort of seen them peaking around the 40%. But as we've talked about this year, they've always in excess of or at least 40% from there, or the majority of the time is 40%. But the fact then that there's actually rising, what this indicates to us is when we're looking at this data, is that this isn't then sort of spreading out. So if we think about sort of the way you'd have a domino effect, if I take an interface down in North America, the other end of that may well be in Australia. So I sort of see the global numbers going up at the same time as the US-centric ones. The fact that I'm just seeing this increase there sort of indicates that the problems are effectively contained or being more contained within that sort of central blast radius. So they're getting better at how they actually sort of contain the impact of these outages when they're having to do the maintenance work and the scheduled work. All this stuff has to go on all the time. We're constantly sort of making changes to network. We're updating cars. We're bringing infrastructure in and out before it fails, making configuration changes to this dynamic environment. But the ability to control the impact of that seems to be working in terms of how we're sort of keeping that blast radius, as it were, to a minimum.
And that's our show. Please give us a follow and leave us a review on your favourite podcast platform. We really appreciate it. And not only does this ensure you're in the know when a new episode's published, it also helps us to shape the show for you. You can follow us on LinkedIn or X at 1000eyes, or you can send questions or feedback to internetreport@1000eyes.com. Until next time, goodbye.